Problem number 45 says there is a 0.3 kilogram ball thrown vertically upward with an initial speed of 10 meters per second. So let's write that down. So this is problem number 45 out of your textbook. There's a ball. It weighs 0.3 kilograms, and it is thrown up with an upward velocity of, what was it, 10? Let me read that again. I think
Yeah,
it was
10 meters per second.
10 meters per second. 10 meters per second. All right. If it's in motion, it has kinetic energy. If the potential energy is taken as 0, find the ball's potential energy and mechanical energy of its initial position at 2.5 meters above its initial position and at its maximum height. So here's, okay, this is a good problem. Here's its initial position, arbitrarily, we'll call it 0. All right? And so once it gets thrown, it's saying that from that point, if the initial potential energy is taken as 0, so they're saying that U naught is equal to 0 joules. That's important. What is its, and then it goes on and it says, what is its, find the ball's kinetic and potential energy and mechanical energies at its initial position, and then at 2.5 meters. So what we need is, for part A, we need kinetic energy, the initial kinetic energy, the initial potential energy, which they kind of give us, and then we also need the mechanical energy. And in your textbook, the mechanical energy is given E, okay? And then for part B, I want you to do all that stuff at 2.5 meters. And then it's not really C, but it says at its max height. Okay? And we'll talk about how we do that in a second. So let's unpack that. First thing I want to do is figure out the initial kinetic energy. So the initial kinetic energy is just 1/2 times the mass times the velocity squared. So its initial kinetic energy is that stuff multiplied together. And if you plug that in a calculator, you will end up with, I think, 15 joules. Okay. Oh, I should probably point this out. Mechanical energy is the difference between potential and kinetic energy. Okay? So, it's the sum of both of them. So, E naught, I'm running out of space here, but E naught is equal to the kinetic energy plus the potential energy. So the initial potential energy then, the initial mechanical energy is equal to K naught plus U naught, and we said that this is 15.0 joules plus 0 joules. So the initial mechanical energy is really just 15. Does that make sense to you guys?
Yeah.
So mechanical energy is the sum of all the energies. So in this particular case, when the ball is in motion, it has kinetic energy. It doesn't have any potential energy because we're arbitrarily choosing the ball's starting position as 0 meters. Now, it could be 10 meters off the ground, it doesn't matter, but we're arbitrarily saying this is our 0 point. Because after all, when we let go of the ball, that's the initial starting point of the ball. So the change in direction, the delta y, starts at that point. So it makes sense to count that as 0. I could count it at 100, but then I got to do a bunch of math. It's easier to choose that point as 0. And since h equals 0, then my potential energy would equal 0, and vice versa. Okay, so they told us that the potential energy is equal to 0. So the mechanical energy is always the sum total of your kinetic plus potential energy. And sometimes there's other energies that we can add in there. But energy can't be created nor destroyed. Okay, so that means that my final energy has to equal my initial energy. Does that make sense? because it can only be transferred. And we're going to assume, we're going to ignore friction because it gets used up for that. Maybe it makes a little bit of sound waves as it travels through the air. We're going to ignore that. We're going to just focus on potential and kinetic energy. So we need to know that to get to, in other words, we need to know that the final energy should be equal to the initial energy. The mechanical energy final should equal the initial mechanical energy. So now, how do we do this 2.5 business? Well, one way to do that is my final energy, which we said should equal 15 joules, is also equal to the kinetic energy final and the potential energy final. All right. For the potential energy, the formula is mgh or mgy, depending on however your textbook wants to write it. But we'll just think of it as mgy.
Wait, that equals the... That's the formula.
That's the potential energy. Okay. Now the kinetic energy will change. It will go down some. Okay? It will go down some. So I could evaluate this. This is my mechanical energy at 2.5 meters, which means there's a kinetic energy at 2.5 meters, and there's a potential energy at 2.5 meters. So I'm going to take the mass 0.3 times the acceleration due to gravity times my displacement of 2.5. All right, that's my delta y. And so what am I saying? Is that after some time, it's going to travel to 2.5 meters. And so now, this is the mechanical energy that we're calculating. Does that make sense to you guys? All right. So now, what do I do about the other stuff? Well, this will have a number, but it's got to be added to this kinetic energy. Do I need to calculate the kinetic energy? Well, I know what it is. This has to, the mechanical energy never changes, so this should be 15 joules. And this is the kinetic energy at 2.5. So I've got 15 joules is equal to the kinetic energy at 2. I'm running out of room here. Kinetic energy at 2.5 plus this stuff should equal 15 joules. Right? All this stuff should be in joules. Okay, so now I've got 15 joules should equal, this number here is actually 7.35 joules. So then I figure out that my kinetic energy at 2.5 should be 15 minus the 7.35. Does that make sense to you guys? Mm-hmm. So, and we may or may not need that. But if I do the math on that, I get 7.65.
So that's the kinetic energy at 2.5.
That's the kinetic energy at 2.5 meters. Okay? So that one's done. We have the potential energy at 2.5. We have the kinetic energy at 2.5. And really the mechanical energy is going to be the same throughout the entire system. Does that make sense? Because the energy can't be created nor destroyed. All right, so now let's do the last part, maximum height. Now this is a conceptual question. My energy should equal the kinetic energy plus the potential energy. All right, well, what is the mechanical energy at this point here? Still 15 joules. Doesn't change it. So now if we go back to our little diagram at the top, we're under the assumption that this object is going to keep on moving till it gets to a maximum height. Do I know what the maximum height is? No. But what is the velocity of the object at the maximum height?
Negative 9.8.
What is the velocity?
Zero.
Oh, that's acceleration.
The velocity at that instant in time is 0. Therefore, what is the kinetic energy at that point in time? 0. Remember, because this is 1 point or 1/2 times the mass times the velocity squared. But since the velocity is 0, that whole thing is 0 plus the potential energy. That should equal 15 joules. So what is my potential energy?
15 joules.
15 joules. Now, can I figure out the height, the maximum height? Yeah, because it's m times g times y. So 15 joules should equal 0.3 times 9.8 times y. Or what is 0.3 times 9.8?
29.4. No, it's not. It's wrong.
You have
I-
2.98.
What is it?
It's
0.3 times.
It's 2.94. Close.
Wait, that's right, because your potential energy is 15 or
Mhm.
0.
Well, 0 plus u, this whole thing can go away, so u equals 15.
So which one's one where you do the half, and is that kinetic energy?
That's kinetic energy. And mgh or mgy is potential energy. So now what's 15 divided by 2.94?
5.10.
Mm-hmm. Mm-hmm. And if we did the dimensions, this is like meters squared over seconds squared, and then everything will cancel out and we're left with meters. By the way, guess what problem number 46 is? What is the max height of the ball in exercise number 45? So this is, you're welcome, that's free of charge. This is the answer to problem number 46. Number 46 says, what is the maximum height of that?